There's a paint in China that makes buildings colder than the air around them, not cooler, colder in direct sunlight. No electricity, no machine, just a coat of white on a rooftop, and the surface drops below the temperature of the surrounding air while the sun is beating straight down on it. That sounds like it breaks physics. It doesn't. The coating reflects sunlight, then sends the heat it can't avoid through a transparent window in the atmosphere and dumps it directly into space. We'll come back to exactly how that works. But it might be the least impressive thing in this video. In the summer of 2022, China lived through the worst heat wave in its recorded history. Not the worst in a decade. The worst since national records began in 1961. It stretched past 60 days. Temperatures cracked records in dozens of cities simultaneously. The Yangtze River, one of the largest on the planet, dried up in sections. Riverbeds that had been underwater for centuries cracked open like desert floors. Hydropower stations in Sichuan, which feed electricity to cities more than 1,000 kilometers away, dropped to a fraction of their output. Factories were shut down completely to free up power for residential cooling. In Chongqing, a city of 30 million people, forest fires burned across the surrounding mountains while residents watched from their apartment windows. And hundreds of millions of people were stuck in cities built around one assumption, that air conditioning would handle the heat. It wasn't handling it. The grid was buckling under the demand. Rolling blackouts hit parts of Sichuan and Chongqing, and even when the power stayed on, there was a deeper problem. Air conditioning doesn't get rid of heat, it moves it. Every unit bolted to the outside of a building pumps hot air into the street below. Multiply that by tens of thousands of units across a dense city, and you've built a feedback loop. The city gets hotter because everyone is running their AC. Everyone runs their AC harder because the city is getting hotter. You're not solving the problem. You're spinning it faster. Studies have estimated that waste heat from air conditioning systems can raise outdoor temperatures in dense urban areas by 1 to 2 degrees Celsius on their own. The cure is literally making the disease worse. So China started asking a question most countries still haven't gotten around to. What if you stopped treating heat as something you fight inside a sealed room, and started treating it as something the city itself has to deal with? What if cooling wasn't a product you buy, but infrastructure a city builds? That question produced the most ambitious answer first. Deep underground in Shenzhen's Qianhai district, several floors below street level, sits a plant that doesn't look like a machine room. A journalist who visited described it as looking more like a factory, a sprawl of pipes, pumps, and industrial chillers, filling a space the size of a football field. This plant does one thing. It produces chilled water on an industrial scale, then pumps it through a network of insulated pipes running underneath the streets, feeding it into building after building across the entire district. Each tower taps into the network the way your house taps into the water main. Cold water flows in, absorbs heat from the building, flows back to the plant to be cooled again. No individual building runs its own chiller. The whole district shares one hyper-efficient cold source. Walk into one of these buildings on a summer afternoon and you won't hear the familiar rattle of rooftop air conditioning units. You won't see them on the roof at all. The cooling just exists, quietly, invisibly, fed from below the ground. An office worker on the 32nd floor has no idea that the comfortable air around her is coming from a factory-sized machine buried several stories beneath the street she crossed to get to work. The conventional alternative would mean thousands of individual rooftop units, every building cycling its own compressor, every compressor dumping hot exhaust into the streets and leaking refrigerant into the atmosphere. All of them fighting the same heat separately, all of them making the streets around them hotter in the process. According to the project's published figures, this single system cools close to 3 square kilometers of public buildings, because one optimized megaplant is dramatically more efficient than thousands of scattered units. The Qianhai system reportedly saves around 130 million kilowatt hours of electricity every year. That's the equivalent of not burning 16,000 tons of coal. Fewer machines also means far less refrigerant escaping, and refrigerants are some of the most aggressive greenhouse gases we produce. Instead of 10,000 small fights against the heat, one massive, ruthlessly efficient one, hidden underground where nobody walking above even knows it exists. That's cooling at the scale of a city district. But one of the oldest solutions didn't require any machinery at all. It required someone 1,000 years ago to build a house in a very specific shape. In the old Huizhou region of eastern China, traditional homes were built with something unusual at their center. A tall, narrow shaft running straight up through the middle of the house, open to the sky at the top. In Mandarin, it's called a tianjing, a skywell. It looks decorative. It's a cooling engine that runs on nothing but geometry. The walls around the shaft block direct sunlight from ever reaching the bottom, so the air down there stays cool and dense. Warm air inside the house rises naturally, floats up through the shaft, and escapes out the top. As it leaves, it pulls cooler air in through the lower rooms to replace it. The whole building becomes a slow, silent ventilation loop. No fans, no power, no moving parts. Just physics doing the work because someone shaped the building to let it. Step inside one of these homes on a July afternoon and the difference is immediate. The air outside might be 38 degrees and thick with humidity. Inside, it feels like someone left a window open to a cooler country. The light falling through the skywell hits the stone floor below. Rain collects there in a shallow pool during storms, adding another layer of evaporative cooling. The architecture isn't just functional, it's elegant. It was solving thermodynamics before anyone had a word for it. There's an 81-year-old woman in Anhui province who's lived in a skywell house her entire life. She's never owned an air conditioner. Her neighbors in newer concrete apartments run theirs from May through October. Studies on surviving skywell homes have measured indoor temperatures running several degrees below the outdoor air on the hottest days. Not a rough estimate. Measured, published, peer-reviewed. And craftsmen in China have spent more than 30 years restoring these buildings. The government recognizes them as living holders of intangible cultural heritage. They're proof that someone solved this problem a millennium ago, and we forgot because we got electricity and stopped thinking about it. Engineers eventually realized you don't need an open courtyard to use the principle. You need the airflow pattern. In Guangdong province, a 68-story tower was designed with internal channels, vertical windpipes, that move natural airflow through the building the same way a skywell moves air through a house. A 1,000-year-old idea scaled up to a modern skyscraper. So district cooling handles neighborhoods. Skywells handle airflow inside buildings. But what about the ground between them? The surface everyone walks on, drives on, lives above. The road under your feet is quietly one of the biggest reasons your city feels like an oven. Traditional black asphalt reflects somewhere around 5 to 10% of sunlight. The road absorbs roughly 90% of the solar energy hitting it. On a summer afternoon, a black road surface can climb past 60 degrees Celsius. In some places, past 70, hot enough to burn skin on contact. And it doesn't just heat up during the day. It stores that energy like a battery. Long after sunset, when you're hoping for relief, it keeps radiating warmth into the night air. That's why cities stay miserably warm after dark, while the countryside 5 kilometers away cools down. Scientists call it the urban heat island effect. Your city is a heat island rising out of the cooler land around it. The roads are one of the biggest radiators keeping it that way. Cities like Guangzhou and Shenzhen went straight at the problem. They started resurfacing roads with cool pavements, a combination of reflective coatings that bounce solar energy back before it becomes stored heat, thermal blocking layers that slow absorption into the road's core, and porous materials that shed heat through evaporation. The same physics as sweat cooling your skin, built into the ground. In field trials, these surfaces have measured road temperatures dropping by 7 to 14 degrees compared to standard asphalt under the same sun. 14 degrees. Same street, same sky, same hour. The difference is visible on thermal camera. Treated sections glow a cool blue, while the untreated asphalt beside them burns orange and red. Across thousands of kilometers of paved surface, that temperature difference begins changing the city itself. Especially after dark, when it matters most for the millions of people trying to sleep in apartments that won't cool down because the road outside their window is still radiating at midnight. Roads pushing heat away at the surface. District plants pulling it underground. 1,000-year-old airflow patterns ventilating buildings. Each of these operates at a different scale, but there's something even stranger happening on the rooftops above all of them. And this is where we come back to that paint. The technology is called passive radiative cooling. It does two things at once that shouldn't be possible together. First, the paint reflects almost all incoming sunlight. The sun's energy never gets absorbed by the building. That part is straightforward. A very white, very reflective surface stays cooler. Nothing surprising. The second part is different. Everything warm gives off heat as infrared radiation. Your skin does it, the road does it, a building does it. Normally, that radiated heat gets reabsorbed by the atmosphere and everything nearby. It goes nowhere. But there's a specific band of infrared wavelengths, a narrow window, where the atmosphere is essentially transparent. Heat radiated at those exact wavelengths doesn't get trapped. It passes straight through the sky and out into deep space. Deep space sits at a temperature close to absolute zero. This paint is engineered to emit its heat precisely in that window. The coated surface is quietly using the entire universe as its heat sink. dumping warmth into space 24 hours a day without drawing a single watt. And because it loses heat faster than the sun can add it, the surface actually drops below the temperature of the surrounding air, in full, direct sunlight, a rooftop getting colder while the sun blasts it. That's the part that stops people when they first hear it. It sounds wrong. It sounds like someone made it up. They didn't. A research team out of Hong Kong developed a commercial version. According to the developers, the coating has cut rooftop surface temperatures dramatically under direct sun and pushed indoor air temperatures down by around 10 degrees Celsius under favorable conditions. That translates to cooling energy savings that can approach 40%. The air conditioning barely has to run. It's already been deployed across hundreds of projects in dozens of countries. Warehouses, schools, office towers. In one reported case, workers in a factory with a coated roof said the upper floor went from unbearable to comfortable without anyone touching the thermostat. A building that cools itself by radiating heat into the vacuum of space. No power, no maintenance, no moving parts, no ongoing cost. Just a coat of paint and the physics of the universe doing the rest. And unlike a solar panel or a wind turbine, it actually works hardest when conditions are worst. The hotter the surface, the more aggressively it radiates. All of this, district plants, ancient airflow, reflective roads, space cooling paint, reshapes the city itself. But none of it reaches the person who's simply standing outside, walking, waiting for a bus, working a shift in the open sun. You can't pipe chilled water to a pedestrian. You can't paint a person. Walk down any Chinese street in peak summer and you'll see the answer everywhere. Neck coolers curved around people like headphones, quietly blowing cool air across their skin. Handheld fans with built-in mist sprayers. Jackets with battery-powered fans sewn into the fabric, inflating slightly as they push a constant stream of air across the body. Construction workers wear them. Food delivery riders wear them. Grandmothers walking to the market wear them. What started as a tech curiosity a few years ago has become as common as sunglasses. These aren't novelties. They're everyday essentials for hundreds of millions of people. The better neck coolers press a small solid-state cooling chip against the back of your neck, right where blood runs closest to the surface. Cool the blood at the neck, and you help cool the entire body. It's the same principle doctors use when they place ice packs on a patient's neck during heat emergencies. Except this version is portable, rechargeable, and costs less than a meal. Chinese electronics brands have refined these year after year into devices that are lightweight, quiet, and genuinely effective. At bus stops and transit stations, cities have also installed standalone outdoor cooling units, machines whose only job is to push cool air into the open right where people are gathering. Many run on solar panels. The hottest moments of the day, when these machines are needed most, are exactly when the sun is generating the most power. The heat that makes everyone miserable is the same energy powering the machine fighting it. Supply and demand, perfectly synced by the sun itself. But here's why all of this, the gadgets, the bus stop coolers, the pocket-sized devices, matters more than it seems like it should. During the 2022 heat wave, heat stroke killed people in cities, not hikers in remote areas, ordinary people on ordinary streets. A delivery rider in Zhejiang collapsed on a sidewalk after hours in 40-degree heat. He was 49 years old. He'd been carrying food to people who were staying inside because it was too hot to go out. The people ordering lunch survived the heat. The man bringing it to them didn't. A cheap wearable cooler that any ordinary person can carry in a pocket and switch on the moment the heat turns dangerous is a genuine line of defense. No district plant or reflective road can reach an individual the same way a device around their neck can. And at a price point under $20, it doesn't ask anyone to be rich to survive the summer. And then there's the most extreme measure of all, the one China deployed when even infrastructure wasn't enough. During the worst stretch of the 2022 crisis, the government sent Wing-Lung drones, large unmanned aircraft originally designed for military work, directly into cloud layers over Sichuan. They carried silver iodide, a chemical whose crystal structure is almost identical to ice. Introduce it into a cloud that already holds moisture, and water vapor latches onto it, freezes, grows heavy, and falls as rain. The cloud that might have drifted past without giving up a drop gets nudged into releasing water. China also fired silver iodide rockets from the ground and deployed aircraft flying directly into storm fronts. The scale of the operation was enormous, the largest weather modification program any country has ever attempted. This is where the science becomes less certain. Cloud seeding only works when moisture is already present. It can't conjure rain from a clear sky, and precisely measuring how much additional rain it produces is notoriously difficult. But during those operations, temperatures in parts of the province did drop, and regions that had been desperate for water suddenly had to prepare for flooding. Whether the seeding caused it or accelerated what was already coming is still debated. What isn't debated is that China was willing to try heat management at the scale of the atmosphere itself. That willingness is the real story, not any single technology, the philosophy connecting all of them. Most countries treat heat as a private problem. You buy an air conditioner, you close the door, you pay your electricity bill. Outside your window, the city gets hotter because of it, and next summer you buy a bigger unit, and the city gets hotter still. China, or at least a growing number of its cities, started treating heat as public infrastructure. Something a city engineers the way it engineers roads, water lines, and power grids. Cool the district from below, ventilate buildings through their shape, resurface the roads so they stop storing heat, coat the rooftops so they reject it entirely. Put a cooler in every pocket for the people in between. None of these technologies eliminates air conditioning completely. Together, they make cities far less dependent on it. The air conditioner cools a room. These systems cool the roof, the street, the district, and the person. The future of cooling may not be a more powerful box on the wall. It may be a city designed not to become dangerously hot in the first place. Which of these should your city build first? Tell me in the comments. If this changed how you think about something as simple as the road under your feet, subscribe. Because a country cooling its cities without air conditioners is a country rethinking energy itself.